Okay, 1.7 sets and subsets. So what is a set? And it's an unordered group of items. So the notation is squiggly brackets, and what we do is we list elements with commas in between them. Okay, a universal set, and we've already talked about this, is the set of all elements, and of which all other sets and subsets are comprised from. Okay, so the notation is S or U. So if we have like the number of elements in set S, or if we have S equals, and then we list the universal set. Okay, an element is an item or member in a set. Common elements is when items are elements in two different sets, and then these two different sets overlap. Okay, a subset is a set whose elements are also elements of another larger set. So the notation is the same as set notation, only listing the elements in the subset. Okay, an empty set or a null set is a set with no elements. The notation is either a null, so this is null, or it's two squiggly brackets with nothing in here. So that would be empty. Okay, and we've already talked about this. N and then the bracket is the number of elements in a set. Okay, this is going to be an integer value. So let's take a look at some Venn diagrams and what these look like as sets. Okay, so a Venn diagram is used to organize information. It's a diagram that uses circles to represent the relationship between sets. Okay, so this large box represents the universal set. So this is every single element in the universal set is going to be within this box, whether it's in A or whether it's in B or whether it's not in A or B, which is going to be out here. Okay, but if we have set A, the notation would be capital A. This is all of the elements that lie in A. Even if they're in B, that's fine. As long as they lie in A, that's going to be set A. Now, we've seen this before, A complement. So this is going to be every single element that does not lie in A. So we have A, and then we have this prime, or we can do squiggly A. Okay, but A prime is going to be A complement, and it's going to be comprised of all of this, not in A. Now, we've seen this before when A and B are mutually exclusive or disjoint, and what that means is A and B is a null set. So this means and. So that means that elements that are in both A and in B, set B, is 0. So they're disjoint. They do not share any common elements. Okay, and then if we have some big set A, and we choose just some of those elements, that would be a subset. So we write a subset with this notation, and this is just saying B is a subset of A. So every single element in B is going to actually be in A as well, but not vice versa. So let's talk about the operators for events A and B. So A and B refers to both events A and B occurring simultaneously. We use the word and, we use the notation, it almost looks like an N. So if I think of the word and I think of that letter N in the middle, it's like A and B. And that's how we read that. This is called intersection. And we use the word and. This would be if two sets overlap, it would be the intersection of the two sets. Now, if we're dealing with or, it's A or B. It refers to either event A or event B occurring, which may or may not be simultaneous. So we use this, it looks like a U, because we call it union. But this is going to be A or B, okay? The buzzword is or union, okay? And this is anything in A or anything in B. And I always say it like that. I'm always A or B. And it's very fluffy. It's very, as long as it's in one or the other, it's in set A or B. So, example 1. If the universal set is the set of all integers from 1 to 5. Okay, so if you actually think about it, it's just 1, 2, 3, 4, 5. Then, which of the following subsets are subsets of S? Okay, so is there a 0 in this? No, there's no 0. It's only 1 to 5. Is there a 1 and a 5 in it? Yes. Is there a 1, 2, 5, and 7? No, there's no 7 in our universal set. And is there a null set? Yes, there's always a null set. So the null set is always a subset of every bigger set. Okay, so let's go ahead and write all of the subsets of the following. So if we were given the universal set 3, we could go 3 is a subset and the null set is a subset. Okay, if we were giving XYZ, X is a subset, Y is a subset, Z is a subset. And then XY is a subset, XZ is a subset, and YZ is a subset. Okay, and these are not ordered, so we don't have to then go list YX. It doesn't matter if those flip. Okay, it's just an unordered list. Then we have XYZ, and then we have the null set. Okay, and that's it. Now 1, 2, 3, 4. So we'll start with the null set, then we'll go 1, 2, 3, 4. Then we'll go 1 and 2, 1 and 3, 1 and 4. Then we'll go 2 and 3, 2 and 4, and then we'll go 3 and 4. Now we're on to sets of 3. 1, 2, 3, 1, 2, 4, 1, 3, 4, and then 2, 3, 4. Now we're on sets of 4. 1, 2, 3, 4. So that one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16. 16 subsets. Okay, write the universal set for the following. So if A has the numbers, and I'm going to write this out twice. Okay, 4, 8, 9. Q has 1, 2, 6. Then we have 0, 7, 8. Oh, 8's already done, so we won't put that one in there. Okay, then we have 3. This is technically the universal set, but when we want to clean up the universal set, we write them in a logical order. So 0, 1, 2, 3, 4. There's no 5, but there's a 6, 7, 8, 9. And that would be the universal set that's comprised of all the subsets P, Q, subset R, subset T. Okay. What about B? We have AGR. Okay, A's duplicated, EI. And then we have POYF. So only one is duplicated. But on a logical standpoint, I'm going to put these in alphabetical order. Oh, there's an F in there. OPRY. There's our universal set. Okay, now reading written sets. So given the following sets, determine each of the following. So we're given that the universal set is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're given set A is 1, 2, 3, 4, 5, 6, and set B is 2, 4, 6, 8, 10. So the number in set A, there are 6 elements in set A. So that's just 6. The number in set B, 1, 2, 3, 4, 5, there are 5 elements in there. Okay, so if it has this n, we're just looking for an integer value of the number of elements in that set. Now, A and B, this is intersection. So what we want to do is we want to find the overlap. This is actually asking for the set. So 1, 2 overlaps, 4 and 6. So the number in A and B is 3. There are 3 integers in set A and B. Now, A or B is going to be fluffy, either or, as long as it's in set A or in set B, we're going to include it. So set A is 1 to 6, and those are nice in order. So let's go ahead and write 1 to 6. And now the extra ones here are 8 and 10. And if we were to count these, the number in A or B is 6, 7, 8. There are 8 elements in A or B.